Pleasant good morning to one and all. In this video session, I am going to talk about cluster analysis. So before to learn about cluster analysis, we should know what is clustering. After defining the clustering concept, then we should know how to ensure the quality of the clusters. Then how to apply the clustering concept in our real life. And what are the challenges of clustering? So these are all the concepts I am going to lecture here. Clusters is nothing but a collection of data objects that are similar to one another that should be formed in a single cluster. So dissimilar object in another cluster. How to define the similar and dissimilar among those objects? We should learn according to the characteristics found in objects, data object. Based on that, we define the similarity between the objects. Accordingly, it should be clustered. In the scientific application, large data set that need to be partitioned into smaller groups. So there are also some clustering concept applied, that is called data segmentation. But in our daily life, so outlier detection is one of the important users today. So the outlier detection in this, one of the functions that is found by using the cluster analysis. So that value that is far away from any cluster, which is not comes under any cluster, because it is mainly it is occurred in the credit card fraud. So we try to detect the credit card fraud by using clustering concept. Some criminal activity that has happened in e-commerce applications, so that also monitor by using the cluster analysis. So next thing, we are going to find how to determine the quality of the clusters. A good cluster method will produce high quality clusters with two values: high intra-class similarity, low inter-class similarity. So the quality of the cluster results depends on both similarity. Second one, the quality of clustering methods is also measured by the ability to discover the hidden patterns, that is called intrinsic pattern, in order to define the cluster qualities. Next, where we apply the clustering concept. For example, so these are all the 4 applications. Every human should aware about it. So for example, marketing, the marketer discover different groups in their customers. What characteristics they find? Characteristics of customers based on the purchasing pattern. So the marketer used this knowledge to develop the target marketing program. Second one, land use. Identification of similar area of similar land use in Earth observation database that can be identified by using clustering concept. Insurance. So different insurance policy holders available nowadays. So we need to categorize the insurance policy holder according to their claim cost. So identify group of motor insurance policy holders with a high coverage claim cost. Here also clustering applicable. Next one, city planning. So city planning, that is identify the group of houses according to their house type, value, geographical location. These are all the main features we should know before to classify the city planning. or classify the group of houses. So we apply the clustering concept in our life, in any applications. So these are all the 4 applications, we are all aware about it. Next we are going to talk about challenges of clustering in data mining. What are the challenges? Take as example scalability. Most of the clustering algorithms work well for small data sets. Suppose we are going to apply large data set for particular clustering algorithm, so which may lead biased results. So we need highly scalable clustering algorithm to cluster the large data set or use the large data set in order to produce quality results. Second one, ability to deal with the different types of attributes. Many clustering algorithms are designed to deal with numerical data or work with numerical data. But most of the applications require the data not only based on the numerical, it does include categorical data, ordinal data, ratio scale data, so different types of data. So we need a cluster algorithm to cluster other type of data in an efficient way, to cluster the object according to the different types of attributes. Third one, discovery of clusters with arbitrary shape. We are all aware about it. The algorithm, many clustering algorithms, determine the clusters based on Euclidean distance, since we are trying to find the distance between the 2 objects. So the distance to find the spherical shape. So, but we want to develop an algorithm that can detect the clusters of an arbitrary shape. You want to cluster the regions according to the several features. Based on that we are going to cluster the regions. So the regions we cannot ensure it is in a spherical shape. So Madurai have a different regions. We are going to group the regions based on several cluster features. In that scenario, the region should be maybe an arbitrary shape. So we need to develop an algorithm to detect the clusters of an arbitrary shape. Minimal requirement for domain knowledge to determine input parameters. So domain knowledge is mandatory for any kind of applications, since the user to input certain parameter in the cluster analysis. We are all aware about it. The cluster result definitely should be sensitive to the input parameters. So if the user, we are not aware about the domain knowledge, we don't know how to give the input for cluster analysis. And then we are not able to analyze the cluster results also. So the domain knowledge is very, very important. For example, medical applications, the people, they should know the domain knowledge. Then only they are able to give proper input. Then the algorithm should be sensitive to produce the results according to the inputs. If the input is wrong, the result should not quality. So for large data set, to determine the quality of the clusters, the users or developers, they should know the domain knowledge to determine what kind of input parameter we need to give in order to produce good quality of clusters. Next, ability to deal with noisy and outliers. From the beginning itself, we learn the purpose of clusters to detect the outliers. Even though many real-world databases that contain outliers are missing or unknown or error data, some algorithms are sensitive to such data that may lead to clusters of poor quality. So we deal the data the noisy data, how to overcome the noisy and outlier data to detect and overcome and remove the data, to alter the data, and then apply the data mining algorithm to produce a good clustering. So that kind is one of the main challenging tasks. Insensitive to order of input data. Some of the cluster algorithms are sensitive to the order of input data and return different results, different clustering results. Since we are all aware about it, we are writing any kind of program in any language, we know what number of parameters, type of parameters, order of parameters we need to pass very clearly. So if it is sensitive in the sense that the order should be in very proper, and then it should be returned different results. If it is insensitive in the sense it is not a problem, we can take the data and process the data set and produce the expected results. But to develop what way to produce a good quality result here, to develop incremental clustering algorithm. That algorithm should be insensitive to the order of input. If it is insensitive to the order of input, definitely it will produce the quality of the results. If it is sensitive in the sense from the beginning itself, it is not, it has produced different clusterings. So that is the main thing. So we need to develop incremental clustering algorithm that are insensitive to the order of input and incorporate user specific constraints. So for example, take a job. This is a job to choose location for new ATM machines in a city. So what are the constraints we consider for finding the locations of ATM machine? So maybe we consider the city's river, or highways, or type and number of customers, and then any other institutions, near institutions. We consider these are all the features, these are all the factors we have to consider. This is a challenging task to find the group of data with good cluster behaviors that satisfy specified constraints. And last, interpretability and usability. What is the use of clusters? So user expect clustering results to be interpretable, comprehensible, usable. This is an ultimate aim of clustering. So to study how an application goal may influence the selection of clustering features and methods. So these are all the features of clustering algorithm. Thank you.